Hello, Professor. My name is Tucker Harbor, and today I wanted to go over our doubly linked list. So let's get right into it. I have some include. So we include the standard library, the IO stream, string, array, and boost string. We wanted to make sure that we include these three down here because there's a couple functions that we use that are in them. We also use namespace std, so we don't have to keep doing std : standard. So we start our class with type name t. That means it can take strings, ints, and other types of variables, and it's more dynamic. And we also have public as an index, our struct index. So we have a t as the value, so it can be any kind of data. We have our position. This one's unused right now, but it's going to be able to, it would be able to keep the position of the specific index. So if you have an index at number 3 and you delete number 2, then you would iterate position down 1. That functionality is not included in this. We also have a previous and a next, null constructor, and a param constructor. You don't have to initialize the position because it's already initialized at 0 there. Outside of that struct, we have entries equal 0, how many entries are present. This is so that we can make sure we're not going for out of range errors. Also, if for instance we had a 14 member or a 14 index linked list and a 7 index linked list, and we say, hey, we want to take the last entry from the 7 index and put it into the 14th, then we can say, hey, does this one have more 7 or more? If so, put it in the 7th position and then iterate all the other ones down 1. If we can do the exact same thing the opposite way, say, hey, we want to take the 14th entry and put it in the 7 entry linked list, we check and see if it has 14. If it doesn't, just put it at the end. I don't actually use that. That's just something I had come up with. So we also have our first and our last, usually head and tail. A null constructor, also an array constructor, so that we can construct it out of an array. We use an array of type t, which is actually a reference to an array of type t with an int n number, so that's why we have this template int n. And then we loop through that array and insert last each data. Our destructor, pretty common. If we have a first, then we say pointer to the first. First is actually the next of first, and then delete the pointer. That way we just go ahead and loop through and delete it. We do an empty check. It's returning false if the first or last is null. And then we have a operator bool here. That way we can do stuff like if first or if linked list, or while. So this would be true. Then we have some insert functions. This one's not being used. I wrote it. It just doesn't really work because there's not a way that keeps up with the index number of the individual indexes. And we can go through that. I just haven't really commented it out or anything like that. We have a data check. Data check is used by insert at position, and it's going to make sure if it's the correct index. Again, it's not really used, but we do have a find functionality embedded into the delete node. I'll be happy to go ahead and make those two different functions if it doesn't fulfill the requirement, but the delete node checks for a specific number and also returns where it was at. So it does find it and it does delete it. So if those need to be separated, I can do that. So let's get into insert first. We have a template type name t, and we don't return anything. It's a member of this class, and it takes t data. So we say the first of whatever double linked list it is a new index with the data there. The previous is null, and the next is first, the current first. Then we say if the new first has a next, then first next previous is now first. So this would be first next. The previous of that would be null up until this point. So we say this is the first. And we do an empty check here. That means if the list was empty and you add the first entry into it, then there would not be a last. So that would mean last is first. So it would only be a one entry list, linked list. Then we iterate the entries. The insert last is the same thing but reversed. So it's pretty self-explanatory here. We'll go over these two after we get through the meat of everything. So we do a display all. We check, hey, if we're at the first index and this is where that bool operator comes in, then what we want to do is we do a for loop based on entries -1, and you just see out that value. And then if you don't have a next, then stop. So if the next of the index is not null, then keep going, but otherwise just stop. And then if we're not at the first, then the list is empty. Delete node, this is the one that checks for everything. So we're going to have a bool for delete check, del check, and ints is the index. Keep track of what index you're working on. And then we do type name double linked list pointer to that index from the class double linked list, and make that the temp index. And always keep that as this first, because we don't have the indices or the positions in the index to work on. So what we're going to do is go ahead and loop through the entries here. This was just for testing. We can remove that, but I'm going to keep it in just for right now. And then we say if the data is in the index that we're currently looking at, then we're checking if we're at the first, because temp index previous would be null only if we're at the first. So if temp index previous is null, and then temp index next is null, is the only entry in the list, go ahead and just delete it. That's the only part that this particular function is called in. You could call it from any other point from a larger, and it would just go ahead and delete everything. But I just wanted to have it just delete the entries in the list there. So we also do entries minus here because we're going to break out of here, and you're not going to have any more deletion there. So we end that if here, and then we keep motoring. So if next is not null, that means if next exists, then at this point we would still be the first. So we say the previous of the next is null. Change the previous pointer in the temp index currently first next to null. Make sure it is. And then you say change the current double linked list first to next to the temp index. So this double linked list first is now equal to the temp index, which is the first next. And then you delete the temp index. And then you say, hey, we did delete something, and then you break. So when you break, you go down to here. We go down to here. And then you say, obviously delete check would be true, so delete check equals false. The entry did not exist. But if it's true, then it tells you where it was deleted from. So let's get back up to where we were. So if the previous is not equal to null, so that means it's not. We're not looking at the first, and we're not looking at the last. If there is a next, we're not at the end. So if temp index next not equals null, then the next of temp index previous is now temp index next, because we're getting rid of temp index. And then the previous of temp index next is now temp index previous. And then we don't need to do this. This was what I was doing was changing the temp index to temp index next, and then deleting temp index previous, which didn't make much sense. Now we're just deleting temp index. And then we get to, if we are at the end, change temp index previous next to null, and then say this last is temp index previous. So the last of this list is now temp index previous, and then delete temp index. And then we say delete del check is true, index is I, that way we can keep track of everything, and then we break down here. So we're breaking up here, but we're also breaking here, but we're not breaking in here or here yet, because it just finishes through. And then we say, if we didn't find it, and we're not at the end of the list, then change temp index to temp index next. So that's how you iterate what you're looking for. And then that's how you delete the node. Now, these two are not commented very well, or potentially at all. Let's check. Yeah, not much commenting going on here, but let me go through what my idea was. So we were going to say we have a double linked list pointer to it, and we're going to make a pointer to a pointer, which doesn't make much sense, so we would probably just leave that out. And then we have a temp int, which is our position, and then we make a pointer to the temp index, which is created here. We have a new index, which we make just nulled out. And then we say, while the temp int, which is our position, is greater than the temp list dot entries, then this entry does not exist in the list. Try a position less than. So we want to make sure we're not trying to have a greater position there than is held in the list. And then we clear out that CN there. So then if we say pos 1, we're going to basically insert first, because this is the insertion for anywhere. So insert first would still come into play, and if pos is the temp list entries number, then insert last. Otherwise, if you're inserting it in the middle, then you're going to say the temp index is now data check. So start at the beginning, and then you're looking for the position, and then you're going to do all that swapping, which is already there. Then we say if the last previous, so that means we have more than one basically, then the next of last previous is now last. And then we do that empty check there. So that really did not work because we're not keeping track of the positions. And the data check is similar. So we're going to be if data to check, which is an index, if the position of the next entry to data to check, because we're starting at data to check 1, is position, then you return that data to check next. Otherwise, do a recurrent data to check there, and that's how it loops through there and gives you the correct position. Like I said, we're not keeping the position of those nodes together, so it doesn't really work out. So let's get down to the main. We're going to have an empty array here, just a null empty array. And I had this data array. I had a really weird issue. I changed some of the numbers here, but they were still stuck with the old values. I had one error, I fixed it, and then when I built the solution again, it still had all the data even though I had changed it. So I closed it out, made a new array, just kept that one in there just for funsies. You don't really need this. I don't think we need it. No, we don't really need that. So I just made a reference to the list and a pointer to the list as well, but they aren't really necessary. So we just have some output for the user, and some variables for the loop here. So this is just going to go ahead, and I was just debugging it here just to make sure that we had everything correct. We don't really need any of this stuff, so we'll just delete it. And then we have a menu with a while loop. And then we also, every time we go through that loop, we say how many entries there are. And then we get that CN with the inputs. Then we have a switch for our inputs. And then the rest of it should be pretty self-explanatory once we start it. So we'll go ahead and do it here. It'll load up. There it is. Ooh, can we get that bigger? There we go. Welcome to the linked list example program. This program takes an input of numbers and adds them to an array, which is then converted into a linked list. Program menu, display the original array of numbers in use. So there's our original array. Then we have 2 is insert into the front or the back. Search for and delete a specified entry. Like I said, my search, my find, and my delete are combined. And then we have display the linked list in the current order. So we'll hit 4, and it should display the same objects here. However, there is an error. Let's go ahead and fix that because I noticed it earlier. It's in display. There we go. Let's see if that works. Wait, fix it. So we have an 11 and 11. Anyway, let's go down here. Program menu. 1. Display everything. 2. Insert a number into the linked list at the front or the back. Oh, also, if you just write hello, only input that in integer. 6. Please only choose options 1 through 0 through 5. There's not a 0. So don't do 0. Okay. So we got 2. Ask if you want to do front or back. Let's just do a front, and we'll make it 300. So it's going to go ahead and display the list for us right now as it is. And then we can do 2 again. Sorry, you got to go down. And we'll do 2. And we'll do 301. And we have a 300 and a 301. So now if we display it again, we'll still have the 300 and the 301. So let's start for search and delete. Delete a number. Enter an integer to check for. Well, we can look through here and see that there's a 12, 14, 55, 96, 30, 11, 300, and 301. Let's just try for 200. The entry did not exist. Of course, because it's not in there. So let's delete 12. The entry was found at position 1 and was deleted. So if we display it again, then we have 300, no 12, and goes down to 301. And then if we display the original, then we still see that 12 there without the 300 and the 301. So that's just the original array. That's all that's doing. Now I can delete basically everything. So we'll do 300 was found and deleted. We'll do 301 so we can delete the front and the back. And let's display. As you can see, we have 5 entries in there. 14, 55, 96, 30, and 11. So we'll just get rid of 11. Now we have 4 entries. Let's get rid of 96 this time. Alright. And then let's add 1 to the end. 2,222. Delete 14. The entry was found at 0 and deleted. We'll delete 30. Found at 1 and deleted. Delete that. And display 55 is the last one. The entry did not exist. That might be weird because it did exist. But as you can see, there's 0 entries there. So the list is empty. So why doesn't it exist? It's because that was the only option that I had written there. So we didn't do an empty check. Probably should do that in hindsight now that I'm just now thinking of it, but that's just how I have it written right now. So if we add 1, we can add 1 to the front or the back. It doesn't matter. So we'll do that. And we have 1. As you can see, we'll display that. And we have 1. We'll delete 1. We're down to 0. I haven't tried this, so let's see if it breaks. We'll add 1 to the back of the list. And it works. So there's my linked list. Everything seems to be in working order. Like I said, I can decouple my find and my delete functions there if I need to, but that's what we have so far. Thank you very much.